All right, it looks like it's 2 o'clock, so we're ready to go. Thank you all for taking time out of your days to attend our SolSmart Developing Solar on Brownfields webinar. So fairly straightforward. We'll be talking about any kind of solar PV development on brownfields, landfills, and contaminated land. We hope you find the webinar insightful. We have 4 different teams here to speak with you about different elements of the solar development on brownfields. And I'll also be doing a short intro here to explain the SolSmart program, which will be presenting this webinar. So SolSmart is a program which gets its funding from the U.S. Department of Energy. Our goal is to help local governments make it faster, easier, and more affordable for residents and businesses to go solar. There are many different types of communities that get involved in our organization, including different levels of municipalities, counties, and regional organizations. And what we do is we provide no-cost technical assistance for communities to help them achieve different levels of designation and recognition. So we have 3 different levels, which are SolSmart Gold, Silver, and Bronze. We have different categories within our organization in order to evaluate a community's solar processes and areas of technical assistance. These, as you can see on the screen, are permitting, planning and zoning and development, inspection, construction codes, solar rights, utility engagement, community engagement, and market development and finance. And today's presentation will actually go over 2 criteria that we usually look at within the SolSmart program, which is C7, which is related to feasibility analysis for solar PV on brownfields, landfills, or other underutilized properties, as well as C8, which deals with installing or leasing land for solar PV development on brownfields or other underutilized properties. We'd also like to mention that this webinar provides AICP CM continuing education credits for those that are interested. And that's just a little bit of background on our program. And if you're interested in our program, please visit our website, solsmart.com. For more information, we'd be happy to speak with any interested communities or individuals from those communities. With all that in mind, I will pass off this presentation to Gail.
Hi, my name is Gail Mosey. I work for the National Renewable Energy Lab. I've been here for 16 years now, and I'm here to talk to you today about some of the NREL tools that we have available for evaluating a site for solar development, and then also the partnership that NREL has with the Environmental Protection Agency on the Repowering America's Lands Initiative. Sorry, I don't seem to have control over advancing the slide.
Sorry about that, Gail. We're going to work on that really quickly and see why that might be. So just hang tight for one moment.
If you're able to advance the slide, I can just say next slide also as an option.
I don't think we're able to do that from our end, so we're trying to figure out why that might be happening.
No problem.
Hi, Gail. It looks like it might be an issue on your end, so if you could exit out of your screen and maybe go through it on a different screen, that might be more effective.
Okay. There we go. Closed and reopened. Okay, I'm back. So just wanted to tell you a little bit about NREL because I think a lot of people aren't familiar with, they kind of know we're out here and they know we work a lot in renewable energy, but don't necessarily know exactly how we're set up. We are originally the Solar Energy Research Institute, founded in 1977, and were designated as a national lab in 1991. Our main campus is located in Golden, Colorado, and we're one of 11 national science and technology labs. We have almost 2,000 researchers working at NREL, which has grown quite a lot since I started 16 years ago. It includes more than 300 early career scientists, students, and support staff. We are managed by the Alliance for Sustainable Energy for the Department of Energy. And are a federally funded research and development center. So that's kind of a long way of saying that the lion's share of our funding comes from federal sources, including Department of Energy. However, we do a lot of work for other agencies and entities. So this kind of area of work and expertise for me started in 2008 when NREL partnered with EPA on EPA's Repowering America's Lands initiative. And repowering is capital, and that's for renewable energy, Repowering America's Lands initiative. And there's a great host of website for repowering with lots of the resources that I'm going to show you. So if you haven't already checked out the repowering website, it's a great resource for this topic. But Repowering America's Lands initiative encourages renewable energy development on currently and formerly environmentally contaminated lands, landfills, and mine sites, keeping in mind that we only want to pursue this if it's in alignment with the community's vision for the site under the initiative. The initiative started out by looking at solar, geothermal, biomass, and wind power. We've expanded to look at things along the lines of resilience and sustainability and distributed generation and things of that nature, but for the most part, continuing the theme of renewable energy and repurposing formerly and presently environmentally contaminated lands, including brownfields. So why solar on brownfields? If you're on this call, this is probably something that looks familiar to you in terms of rationale for using brownfields for solar development. It's a great opportunity to provide power to communities, especially if you're looking kind of for a distributed power generation option. It's a good sustainable land development strategy, so kind of works into that overall strategy that you might have for your area. You can leverage existing infrastructure in many cases. A lot of these sites already have roads and transmission that are located nearby, so you can leverage that existing infrastructure for your solar development. You may be able to improve project economics through reduced land cost and tax incentive. That all, of course, depends on the site. You all probably know that in some areas, it may be a less expensive option to use brownfields because that land is reduced in value. And then in some cases, you may receive some tax incentives to develop that land. And then there may already be kind of a streamlined zoning and permitting aspect to things. So for instance, if you're working in an area where it's already permitted for a certain type of use, that use may match well with installing solar. So you might save a little bit of time there with your permitting and your zoning considerations. So now to talk to you a little bit about EPA's Repowering America's Lands mapper. The mapper, I would say, is really probably the bread and butter for repowering. It's an extremely powerful and useful tool, and I encourage everybody to check it out. What the Repowering America's Lands mapper does is it took inventory of tracked sites from EPA databases and then from some state agencies, and it mapped those sites and then applied some screening criteria to those sites to figure out whether or not those sites might be high potential sites. And they did it for several technologies. We're talking today about solar, so I'll mention solar. But so they identified high potential sites for solar based on certain screening criteria. One of the screening criteria was the solar resource availability, which NREL was able to provide. And then Department of Homeland Security, we received information on highways, railroads, transmission lines, substations, and then some states were able to contribute some site data for the project. So this is just a snapshot of what you might see if you go to Mapper and you want to drill down a little bit into your state or your area. So for instance, you might want to identify sites that are high potential for solar. You would just input those that criteria into the Mapper and let it know that it's a very user-friendly tool, but let it know that those are the sites that you're interested in. And then it kind of gives you more of an overall picture, which is in the bottom of your screen. And then if you want to drill down into the sites and look a little bit more at a specific site, maybe you're familiar with the area or something piques your interest about a certain site, you can click on that site and you'll receive information more specific to that site. So about the renewable energy resource availability, including solar, and then also some information about the cleanup status and other things of interest on the site. So just quickly, I just wanted to run through the different criteria that we use. I won't spend too much time on this slide. I wanted it in there kind of for reference. But we look at to take all those sites and to identify really which ones are the high potential sites or higher potential sites. We took a few different criteria and used them as screening criteria is what we were calling them. So we looked at the solar resource availability for the site, the acreage of the site, disintegrated road and transmission, and then also existing conditions at the site like shading and slope and any potential obstructions. And so that screening criteria was applied to the site to filter out sites that maybe just wouldn't be appropriate for siting solar, and that left us with the sites that we considered higher potential for development. So another tool that we've got here for EPA repowering America's lands is the electronic decision tree tool. NREL worked with EPA to develop this. Basically what this decision tree does is it takes you through, it's a free downloadable tool. It takes you through the process of answering essentially some questions about the site, and it's easy to go through, it's super user friendly, and you're for the most part, if you know the site, you're going to know the answers to the questions. But if you don't, or if there's any confusion, there are little boxes that you can click on that would give you some additional information about what the tool is looking for in terms of the type of response. So you could work through that tool to figure out whether or not your site is high potential. So I like to recommend that people kind of start with the repowering mapper and then go to their decision tree tool. And this is just a little bit more information about the decision tree. It kind of walks you through a series of yes, no, and skip questions. And there's supplemental information to help guide you through the process. And then here's a screenshot essentially just to show you. I like for people to be aware of kind of what they're going to see as they're working through the process. In the lower part of the screen, the purple is just an example of a question. And then behind it, in the background is just some information about what you might find if you were curious to get a little bit more detail about the question. And then here's your report. This is what you would find at the end as you walk through the process. That in green, it's showing the next steps that you might want to take. In the darker green in the background, it says, congratulations, you've identified a site that is high potential for solar development, and you're going to want to go ahead and follow these next steps that are highlighted in this lighter shade of green. So here's a little bit more of the repowering resources. I like to highlight these because I think they're such a great resource, and you may or may not be aware of them, but they're a great resource in terms of kind of making the case for your development. So for instance, if you're working in the community and you want to make folks understand why this might be a good reuse for your site, there are some good success stories on the repowering site There's a tracking matrix, which you can kind of understand what else is being done kind of around you or some other good examples. There's a benefits matrix, which lists some of the projects and the benefits associated with them. So you can, kind of point to those sites and say, oh, we have a similar site to this, and these were the benefits that they appreciated, and we could likely appreciate these benefits as well. And then there's also a best practices guide for siting solar on landfill. So that one is very specific, great technical guidance document on siting solar on landfills. And then getting a little bit more into some of a couple of the tools that NREL has that I also think are really good. So I'm thinking, you start with the mapper, you identify a site, and then you go to the decision tree, and then you might want to use something like PV Watts, which is a free, again, downloadable tool at pvwatts.nrel.gov. And basically what it allows you to do is kind of draw the footprint for your site just by a few simple mouse clicks in the location where the site would be located. And it gives you an estimate of the energy production and the cost of energy. So it's just a really good tool to kind of get an idea of what the economics might look like at your site, and then also the energy production. And then we have the system advisor model. We call it SAM, and essentially I think system advisor model is next step from PV Watts, where you're going to want to have a little bit more information about your site to use system advisor model. It's still really user-friendly and downloadable to use, but as far as the inputs go, there's a little bit more requirements for the information that you may want to gather. So if you're interested in running the system advisor model, it's something that you might want to take a quick look at and figure out what your inputs are, and then kind of start gathering those inputs and start running through it. It also has some good default inputs, so it can kind of let you do an initial pass, and then maybe you can refine the analysis a little bit more. But it's a technology, performance, and financial modeling tool. So that might be something that you want to turn to after you've run PV Watts and said, well, this is still looking really good. Let's do one more step with this and look at the system advisor model to see how things are looking with it. And here's just an example of the reporting that you might find from SAM. As you work through the process, it'll give you annual energy capacity factor, LCOE. So as you can see, it gives you a little bit more detail than PV Watts. And that's my content for today and what I wanted to share with you. So I will, pass it all along to our next presenter.
Thank you very much, Gail. So our next presenter is Ashley Bennett from Acreage. So she'll be presenting a little more on the vegetation concerns around brownfields. I'd also like to mention that we also have a section for questions available within the GoToWebinar toolbar. So feel free to send those our way, and at the end of the webinar, we'll run through a couple of them with our panelists to get their take. But with that in mind, I'll pass the screen over to Ashley, and we'll go on to our next presenter.
All right, this is Ashley, and let me know when you guys can see my screen. Am I ready to go? Can you guys see my screen all right?
Yep, we're all good to go, Ashley.
Okay, great. So as Danny said, I'm with the Electric Power Research Institute, and at EPRI, I do a lot of work with utilities on vegetation management and biodiversity conservation on utility lands. And one of the areas that I work on is vegetation management at solar sites. So I've been asked to give you kind of a big overview on some of the considerations you should be thinking about when you're thinking about incorporating vegetation to a solar brownfield. So in general, we have three big categories. No vegetation, so you choose to keep it bare ground or maybe use gravel. You may select to use some sort of non-native vegetation, which may be a cool season turf grass mix as an example, or you may select a regionally appropriate native seed mix for your location. So when you're thinking about, I need to change the panel here so I can see my slides. So when you're thinking about your vegetation at your particular site, there's some considerations you want to think about. And the first is the site conditions. So what type of soil do you have? Do you have sloping at your site? And do you have an existing vegetation? This will affect the type of seed mix you're going to want to select, as well as site preparation strategies, so the steps you want to take before you actually do any planting. You also want to think about the height of your solar panels at your site, because then this will again affect the combination of plants you select to use in your seed mix. So we really want to think about the height of the vegetation and whether or not that will result in any shading on your panels. And then also, when you're thinking about your seed mix, do you want to have any biodiversity benefits at your site? So pollinators are one that is being increasingly used at solar sites. So thinking about what plants do you want to select to support pollinators, whether that be native bees, honeybees, native butterflies. So you're going to want to select species that bloom across the flowering season, species that provide pollen and nectar resources, or host plants. And then also, where do you actually want to put that pollinator habitat within the site? Do you want to actually use it between the panel rows? Maybe you want to use it around the perimeter on the inside, or incorporate it into a hedgerow where you get some screening, maybe some wind blocks, but also get some biodiversity benefits in a hedgerow. Planting techniques you will also need to think about. So your row width will potentially impact the type of equipment you can use at the site. So if you did happen to select a native seed mix, depending on the width or spacing of your panel rows, you may not be able to use a native seed drill. So then you might have to think about using hand broadcasting or hydro seeding at the site. You also want to keep in mind that your panels will modify your soil moisture and lighting, because the panels themselves will cast shade. So you may want to consider using different seed mixes under the panels versus in the rows. If you did not select to use any vegetation at the site and you're in more arid regions of the country, dust may become a problem at your site. And I've also been asked the question, okay, well, if I do use a pollinator mix and we have a lot of flowers, is that pollen from the plants actually going to accumulate on my panels? And I don't think we have a good answer for that question yet. My slides are not wanting to advance anymore. Any suggestions? Okay, here we go. I'm back. So if you're actually, so those were more general recommendations for a solar site in general, but when we're thinking about vegetation management in a solar brownfield, there may be some additional considerations. So with utilities I work on, a lot of our sites are CCR sites, or old coal ash ponds that have a synthetic cap. So if you have a brownfield that has a synthetic cap, this may reduce the depth of the soil you have to work with, which will again affect the soil moisture. So that cap may actually be a barrier to the establishment of your vegetation. And that will again affect your seed mix, thinking about what plants are going to do better in a shallow soil layer. And do you actually need to increase the soil at the site to improve plant establishment? Water runoff may also be more of an issue at brownfields. So brownfields oftentimes have degraded soils. The soils may be compacted. Again, if you have any sort of synthetic cap at this brownfield, this may modify your plant establishment and increase water runoff. So you may actually need to think about some mitigation strategies for water runoff and soil erosion. So thinking and modifying the types of vegetation you plant at the site, thinking about increasing planting density or cover. You may need to modify your planting time, as well as think about using some type of cover crop or nurse crop, as well as incorporating erosion control fabrics to the site. If you happen to have a lot of water runoff and soil erosion, you may even need to consider bioswales or detention ponds for your solar site. Another potential issue with brownfields is soil contamination. So if you do have soil contamination at your site, this can impact your vegetation, can impact plant growth, it can affect plant size, seed set, and even heavy metals have been shown to accumulate in pollen and nectar. So these contaminants can potentially have a negative effect not only on plants, but potentially the biodiversity that we're attracting into the site. So research has shown that pollinators, specifically bumblebees that feed on pollen and nectar that have heavy metal contamination, it reduces their survival and ability to reproduce. So in general, when we're thinking about establishing vegetation at a solar brownfield, I do advocate the use of native vegetation. When you're thinking about what type of vegetation you want to incorporate into the site, native vegetation does have several benefits. One, you're helping to establish and recreate native habitat for whatever region in the country you're in. The use of native plants have several benefits. One, they're oftentimes adapted to the local environment, meaning they're going to be drought tolerant, for example. Native plants typically have very deep roots compared to a lot of our turf grasses. So this really does help reduce water runoff and decrease soil erosion, and it can improve the health of the soil over time by increasing soil carbon and nutrients that are accumulating. Native vegetation can certainly help support pollinators, especially if we're including a lot of floral resources into that mix. So we can be attracting bees and butterflies and other beneficial insects. It also supports nesting and overwintering habitat for these insects, as well as grassland birds. It can support other biodiversity such as bats, mammals, and even reptiles at the site. I do want to stress that we do want to make sure that we're not actually creating a sink, meaning we're creating this great habitat, but it's actually having a negative effect on some of the biodiversity. And this can potentially happen in a couple ways. One, as I mentioned earlier, we may actually see bioaccumulation of contaminants in the plant material. And then if our biodiversity, like our pollinators, are feeding on that, it can have detrimental effects on those species. We also want to be thinking about when we actually go out and do maintenance on the site, because improperly timed maintenance can also negatively affect biodiversity. So a couple examples, thinking about the time of when you actually go out and mow. So you wouldn't want to go out and mow during peak bloom. You wouldn't want to go out and mow in the spring during bird nesting, and also thinking about the chemical inputs going into the site. So we certainly wouldn't want to be going out and applying chemicals during, again, peak bloom, which could negatively affect our pollinators and other beneficial insects. Just really quickly here at the end, I wanted to highlight the use of remote sensing technology to help in vegetation management. So the use of satellite data as well as drone collected data can help monitor invasive species. It can help detect invasive species that may be encroaching into the vegetation you established, as well as determine the percent cover of invasive species. It can help assess the establishment of pollinator habitat, both in terms of flower cover, as well as how well did that habitat actually establish. Do we have any bare spots in some areas that we may need to go back and do some reseeding? And then also, if you do have problems with water runoff or soil erosion, remotely sensed data can help you track that change over time, as well as determine if you maybe have differences between some of the types of vegetation cover you've selected to use. And then finally, satellite and drone collected data can help you determine when you need to go out and do management. So as I mentioned, if you do happen to see some encroachment of invasive species, using remotely sensed data may help you go out and address it earlier through mowing or a spot herbicide application to prevent its spread. Or as I mentioned, if you do have problems with soil erosion, this can help you see areas within your solar site that you may need to go do some reseeding. I know I went through that high-level overview very quickly, so I welcome any questions at the end on vegetation considerations for solar brownfields. Thank you.
All right, Ashley, thank you very much. Very insightful. So our next presenters will be Rob and Dan from Stantec, and they will be talking about a few case examples and some other information. So I will pass the screen over to them.
All right, good afternoon, everyone. My name is Robert Molnar. I'm the subsector leader for solar for US Power for Stantec. Stantec is a 22,000 person multidisciplinary consulting firm. We've got a significant amount of renewables experience, including over 11,000 megawatts of solar and wind design combined. I'm going to be joined by my colleague, Daniel Kramer, who's going to be assisting in this presentation as well. So we're just going to go through and discuss some of our considerations for brownfield sites on solar farms. As part of our presentations, we always deliver a safety moment. One safety moment related to all solar facilities is during construction. There are a significant amount of ongoing activities taking place in conjunction with one another. So it's always prudent to take extra caution to know your surroundings. Some of the items involved are open trenches, moving vehicles, overhead line work, and live electric lines. So here's a quick overview of the agenda. We're going to cover a few sites that we've designed on brownfields, and then we'll move into some of the benefits of solar PV, discuss some of the market trends, and then work through some of the civil, structural, and electrical considerations. So the first site is a Hamden landfill site in Connecticut. This was the first virtual net metering project in the state. This site was designed on a capped landfill, which obviously presented unique challenges. Our cap was approximately 5 foot below grade, so there was no possibility to impact the surface. So for this project, we used a ballasted racking system, so we did not have to use the piles that would puncture the cap. Also, we needed to have above ground cabling, as underground trenching was not permitted. Similarly, this is a little larger site. This is New Road Solar Farm in New Jersey. This is a 13 megawatt project. Again, we used a ballasted racking system. This site was fixed tilt ground mount. We used above grade cable tray in lieu of trenching on this site. We also set all of our equipment pads off the cap, so we were able to utilize our typical foundation construction of a concrete pad for the electrical equipment pads. This site required extensive discussions with the landfill owner, utility, and the system owner to ensure the integrity was maintained for the landfill.
Yeah, hi, can you hear me?
Yep.
Okay, perfect. Hi, my name is Dan Kramer. This is an example of a brownfield site we did here in Ontario, Canada. It's Nanacoke. It's a 44 megawatt AC solar farm. Originally, this was the site of the largest coal-firing generating station in North America. We worked with a local EPC team to basically do the design, to help with the process, and to help make sure the project got built in a timely manner. Stantec, in this case, helped with the detailed design, structural, electrical, civil, and stormwater management for reuse of a local farm field, as well as the pre-existing coal pile location, since it couldn't be used for anything else. Some of the benefits that we've determined, or we've seen with using brownfield, is you can get very good reuse of contaminated lands, the soil that can normally not be used for anything else. Brownfield sites make very good locations for this. Generally, they are positively received by both the community and the government. They help mitigate climate change. They've been shown to be one of the cheapest ways to produce electricity. They're passive revenues, as they just sit there and generate. If they are next to an existing substation, as in the case in the picture, it makes it quite easy to tie it in and to work with. And you can also repurpose decommissioned materials that may have been present on the site for road construction and for various elements.
So here we're going to get into some of the market trends that we're seeing. There's over 450,000 brownfield sites in the U.S. 27.5% of U.S. electrical generation is currently being generated from coal. The U.S. forecast for solar in the U.S. is approximately 15 gigawatts per year of new installations, and the global forecast is approximately 144 gigawatts per year of new installations. So getting into the civil design, some of the items that you need to consider. There's a limited amount of existing data on the site for the underground utilities and survey. So you need to be aware of what may or may not be buried below grade. The site runoff is required to be treated before it can be discharged. Your earthworks are limited due to the contaminated material on the sites. As previously discussed by one of the other presenters, there's potential for dust, so you need to minimize that dust that leaves the site. And you also need to protect your electrical equipment from floodwaters. A few more considerations when converting a decommissioned coal site into the renewable solar facility. It doesn't come obviously without its challenges. Vegetation establishment needs to be predetermined and worked with the owner to determine what kind of vegetation should be installed. There's ponding water in isolated facilities. Again, you need to set your 100-year flood level to protect your electrical equipment. And that involves raising your pads a certain level above grade. Utilizing existing pump and treating systems. Maintain the existing ECA approval. And 2 items for your ballasted racking systems is to either use a precast concrete ballast or a pour-in-place ballast.
So when you're dealing with various brownfield sites, you may have unknown or unsure of soil conditions. And so in the case of like landfill sites where you have a cap system, you certainly cannot use a piling system, as you obviously cannot puncture the caps. In cases where you're using repurposed coal fields, for example, highly corrosive soils may cause premature damage and corrosion to the steel piles, so piling needs to be treated with a retardant. Selection of concrete types and must be compatible with soil chemical makeups, and you also may need additional reinforcing bars to ensure that the concrete structures maintain their structural integrity. One of the things we should highly emphasize is that when you're repurposing a brownfield site, don't take the geotechnical studies too lightly. Soil conditions can vary, very quickly, so you need to make sure you have a very thorough analysis of the site to ensure that you've covered off all your bases and make sure you've got everything in place. Some of the electrical considerations that should also be considered of the soil pH can significantly damage or corrode or reduce the life of your cabling system, so you have to consider that. Grounding of your system near an existing repurposed substation can be difficult because of the unknown integrity of the existing system, so if more detailed electrical studies and analysis may be necessary. Highly variable soil can be difficult to manage cable sizing or ampacity requirements, and as such, your design may require a more conservative approach to ensure your cables are sized accordingly. And finally, if you do have a landfill site, for example, that you have the cap, you may have to employ, or you likely will have to employ, a cable tray system or some sort of cab system. And finally, some of the lessons we've learned or we've experienced with dealing with the brownfield sites in our development, while permitting may be available to be repurposed, it can be difficult sometimes to try to make sure that whatever you've got in place is the local authorities meet all the requirements to repurpose it due to previous setup. It's important to perform your due diligences up front. High infiltration rates with very little vegetation on coal fields, for example, may be difficult to prevent soil erosion. You need to verify approvals for dust control during and post construction to make sure you meet with your environmental requirements. Balancing of earthworks to avoid removing contaminated soils from site is usually quite important. Visual screening added to buffering neighbors will help keep complaints low for those who don't like the look of solar farms, but can have impact on your setbacks and encroachments. And it's also important to have regular on-site supervision of the installation and the construction process to make sure that if you run into any challenges during implementation, that they can be dealt with quickly and efficiently. We'll be here if there's any questions after that. Thank you.
All right, thank you very much, Dan and Rob. So we're going to move real quickly to Cameron Bailey from the Met Council. We'd also like to mention that this webinar will be, a recording of this webinar will be available to all attendees and registrants, and we'll be sending that out within a day or so. It'll also be available on YouTube on our Go Soul Smart YouTube channel, so you can feel free to see it there as well. And with that in mind, I will pass the slides over to Cameron.
Thank you kindly. Audio good and visual good?
Yep, we're all good.
Beautiful. All righty. Thanks for the intro. Cameron Bailey, I'm a Senior Regional Planner and Solar Advisor at the Met Council, which serves as the Metropolitan Planning Organization, Transit Authority, Wastewater Treatment Agency for the Twin Cities Metro. That's Minneapolis, St. Paul, up in Minnesota, 7-county jurisdiction, and about 3.6 million people in our jurisdiction across 188 bodies. With that, hop on into it, where I'll be presenting on the Minnesota Brownfields initiative, where we're specifically focused on solar enclosed landfills as a target brownfield. So I'm presenting on how the Brownfields initiatives was developed and what it's been doing, which requires me to discuss how it came to be. So back in 2017, the Minnesota Solar Pathways Project, which you see represented here on the left, was initiated through the U.S. Department of Energy with funding. That is a statewide research and feasibility partnership that models future renewable energy generation and hosting costs. The project developed a solar capacity report, one of the few you see at the bottom of the screen, which found that with everything as it is today, Minnesota could achieve 10% solar generation across the state by 2025 and a 70% blend of solar and wind generation by 2050 at costs comparable to natural gas generation. So once that analysis was done, the Solar Pathways Project began to identify statewide development opportunities to support these technically and financially feasible goals. And it's there that the Minnesota Brownfields Initiative, which is a statewide partnership focused on creating an environmentally, fiscally, and socially responsible development pathway for solar on Minnesota's closed landfills, came about. So we started that initiative with Minnesota cities and counties that were enrolled in a solar best practices and technical assistance program called SoulSmart, which we heard about earlier. So what we did is we asked those cities, counties, as well as the various technical assistance institutes available at SoulSmart, what are some really good and large solar development opportunities they saw in their communities? And closed landfills came to the top of that list pretty quickly. By the way, all these little sun icons you see on the right are actual approximate locations of the 114 closed landfills managed by our state's pollution control agency. Now, I highlight that number not to just denote scale, but also to denote that we've developed a consistent statewide database for solar resource potential, environmental, physical, and waste features of the sites, as well as high voltage transmission proximity, to more fairly assess the potential for solar development at all of these sites across the state. And the idea is that, we want to be able to provide as much as much information so communities can be as informed as possible and deciding what sort of development opportunities they want to take advantage of these sites. And I think in large part, because of this consistent data set we have, we are able to collectively arrive at three major reasons why a lot of our Minnesota cities, counties, and communities really like the idea of solar development on their closed landfills. The first of which I would say is it's environmentally degraded land that's pretty difficult and expensive to otherwise develop. Two, typically you have very few trees and thus have a higher solar resource potential. And three, typically you have landfills because you had enough people that you needed a landfill in the first place, which means there's, in a lot of cases, at least in our program or for our site, you're relatively close to electricity load as well as transmission. So kind of like the big factors that really drive the feasibility of a project, at least on the face of it. Now, I'm pretty convinced that these site aspects resonated with a lot of folks for ideal solar development and community development because of the number of partners from across all the sectors, the political aisle, who've come on board to support this initiative and the larger Minnesota Solar Pathways project. And I think that's why in the state of Minnesota, we're not asking, are Brightfields a good idea, but rather, how do we most effectively and responsibly capitalize on this great idea? And that's what kind of led into legislative action we were ultimately able to support and get passed at the legislature last year. We worked with those local governments we originally identified through the Soul Smart program. We worked with the solar development community through the Minnesota CEA chapter, environmental groups, and electric utilities to ultimately elevate the desire for a comprehensive statewide study to the legislature, and it actually got passed. So here on this page, we highlight the three goals of the state's legislatively funded solar and closed landfill study. One, identify and assess properties in the program with the highest potential for solar energy production. Two, identify potential barriers to solar energy production, but also potential pathways to address those barriers. And three, develop policy recommendations that would facilitate solar energy production in support of local and state sustainability goals. And at the bottom, you can see our timeline. This study, we got $300,000 allocated, and we also have an end date. So by December 21 this year, the study needs to be completed with recommendations on how the legislature should support Brightfield development in the state of Minnesota going forward. I think as we've heard from some of our speakers, this is not a Minnesota-specific pie-in-the-sky area of interest. Is there, in terms of Brightfields, there's already over 200 operating across the country. And as you can see in this picture, one of the ones we have in Minnesota, they are typically not at odds with other surrounding land uses. In the top of the picture, you can see one of our wastewater treatment plants. You can see a large commercial industrial district, residential housing across the street, and this is actually about 1 mile from the Minnesota River and about 4 from the Mississippi River. So a lot of really environmentally sensitive land. And this was something we were able to bring online through our organization as a community solar garden in 2018. Matter of fact, I want to include some headlines for new solar and closed landfill development in the last 4 years from other upper Midwest states to demonstrate that our region of the country is a viable Brightfield market. So Minnesota, Wisconsin, Illinois up here. And that was also a big part of, how we were able to get buy-in from communities. A lot of times when people ask us, who else is doing it? So being able to point to a similar climate context really helped by support and belief in this possibility in Minnesota. So now I'd like to take a couple minutes to look at 6 of our Minnesota community champions who signed and submitted letters of support to the state legislature for solar development on their closed landfills, or are openly interested in seeing such development in their community. So these 2 communities are basically on opposite sides of the state of Minnesota. One over in Becker County, where there's still an operating closed landfill next to it, and then this other one to the right in the city of Duluth. Now, this one on the left is interesting because there's 3 electric utilities: a muni, a co-op, and a publicly traded and owned private utility, all within a quarter mile of the site in a fairly large city about 3 miles down the road. And on the right, city of Duluth, that site's next to a municipal airport, as well as adjacent to a residential community just east of it. And as you can see on the site or the page going through this, give you a sense of scale and the diversity of scale of these sites between the cap and the site footprint as a whole. This one, we have the city of Albert Lea, which is pretty far south of Minnesota. and then Olmsted County, which is in the southeastern portion of Minnesota. You may notice, in terms of the visuals, things that look a lot more like ag land relative to the last picture that they kind of are in prime ag country around in Minnesota. And with these ones, you can see once again, sites over 100 acres in size, directly adjacent to a municipal airport for this one on the left, as well as residential uses and a water body and some wetlands. And then on the bottom right, over in Olmsted County in the township of Orinoco, seeing a lot of new subdivision development in the area, which is as well as an operating mine in a stream. And then last two here, these two are located in the metro area within the jurisdiction of my organization. One on the right is located literally right off the Minnesota River, about 3 miles from where that feeds into the Mississippi, and the other one in the city of Ramsey, which is about half a mile from the Mississippi River. And both of these are adjacent to a lot of residential land uses, commercial, as you can see, another municipally owned airport, and showing the diversity of these sites, what they have in common, what's different. The major strain of continuity is that the cities that each of these sites are located in are, they're champions for solar development on these closed landfills. Now, remember, these are just closed landfills, and that's our focus as the initiative. But cities like Virginia and Mountain Iron, Minnesota, who were originally interested in developing solar enclosed landfills, were ultimately inspired to begin looking somewhere bigger for them, which would be the iron ore mining operations in their community. And this is in the Iron Range region of Minnesota, which I think you can see why they rolled their interest that way in terms of the scale of potential development. So this is something where, we started off with a question of where would larger scale solar development be most amenable to your community. Originally, we're looking at landfills, and for them, they rolled and looked much larger to something else that had more applicability in their community. And you can see in this last community here, this is in Dodge County, which is near the top of the state for wind and solar production per capita. And I think this is one of the best slides to discuss Brightfield from my regional planner brain perspective, in the sense that they're a very elegant land use option. You can see in the upper left an already installed 5 megawatt solar array that was leased on farmland. And here in Minnesota, tensions have been growing as more farming communities feel the loss of that farming industry to solar development on ag land. So, Brightfield development allows for tax-based revitalization with land that would otherwise be undevelopable. That keeps from additional solar development occurring on ag land. And additionally, with the largest, Minnesota having the largest community solar garden market in the country, many Minnesota communities are becoming familiar with seeing ground mount solar sites adjacent to land uses we see in the slide. The residential, the high school at the lower right, an operating gravel mine, wetlands, and ag land. So, what are the value adds communities see in the solar development potential of these closed landfills? And I think what they're seeing thematically is pretty in line with the council, my employer, the Met Council's own policy outcomes of, you can see on the right, stewardship, prosperity, equity, livability, and sustainability. And what we have here, these two maps, is some overlap between our pollution control agency's mapping of areas of environmental justice across the state of Minnesota and the location of our closed landfills. So for us, the Brightfields Initiative, rather than stating what communities' value adds are, we present them with the data, we support them in education, and we ask them, how can solar development on your closed landfills support the existing goals and needs of your community? And that's something the Brightfields Initiative continues to help with. So I just want to go over a quick list of our upcoming methods of support for the next year in a techno-economic analysis report for the city of Ramsey that the Council of Development Finance Agencies is preparing for us in partnership and support from the U.S. EPA's Repowering program. We have a market mixer bringing together Minnesota communities with closed landfills together with solar developers on February 20th, 2020 to help facilitate that development. We have the statewide report and statewide assessment coming up, and then other education opportunities. And then, I know not everyone, if not the majority of people on this webinar aren't from Minnesota, so I want to provide some of the resources we use that are applicable nationally and most of you will probably have locally as well, in terms of your state departments around commerce, pollution, and natural resources. And with that, I cede the floor.
All right, thank you very much, Cameron. It was very insightful. And at this point in time, we're on to the Q&As, which I will just put my screen up here for that particular section. So this is just a short acknowledgement and disclaimer that this report was prepared on account of work sponsored by an agency of the U.S. government, but there is no agency or warranty or implied legal liability for the U.S. government. Just a short disclaimer there for clarification. And now we're on to the Q&A section. So we're a little bit short on time, so we only have time for a question or two, but I will unmute all of our remaining presenters, and I'll give everyone a minute or two if anyone is interested in sending in any further questions for any of our remaining panelists. Feel free to do so now, and I will start presenting those questions in a minute or two. All right, so it looks like we've got a few questions that have rolled in. So one of the first questions is, how easy is it to get permits for installing solar on water and wastewater treatment facilities with significant acreage of available land? And what permits are required to start these sorts of activities? I guess this is open to anyone who's interested among the panelists who has anything regarding that topic, any feedback regarding that topic.
This is Cameron. I could hop in right quick. I know on our end, we actually developed these community solar gardens at two of our wastewater treatment facilities to date, with a third one planned as a part of a larger joint RFP. And one of the first things we did was geotechnical exploration analysis. We have something in Minnesota called the Voluntary Investigation and Cleanup Program through our state's pollution control agency, which is basically doing a historical analysis of the site. I believe we actually did an EAW as well, environmental assessment worksheet, solicit a lot of community input and really benchmark what are the environmental, hydraulic, hydrology, and waste characteristics of our site in and of the first place, the age of it, what's in the fill, really building a full picture of what's under the ground to really drive what I think some of our other speakers got at. What are the potential solutions in terms of how to engineer and design a solar array that would support the number one goal of the site, which is to manage environmental waste degradation, leaching, and public health impacts. From there, kind of move down the regular pipeline of stormwater pollution prevention permits, conditional use permits, through I believe that was through the city, in both of those scenarios, so having to go through their process. One of our communities, they actually have an interim use permit rather than a conditional use permit. But yeah, more work on the front end in terms of the environmental and waste. I guess that kind of context of the site. So like some of our developers may be able to be more helpful in that as well. But for our sites, they're also kind of unique in that the landfills at our sites are specifically incinerated ash landfills. So it's kind of nice in the sense we know exactly what's in there and have historical records tracking how much went into there versus I think a lot of the other closed landfill sites we see across the site where what's in there and what's happening can be a bit more variable.
It looks like we've got time for one more question. It's also worth mentioning that we will be following up for individuals that are sending specific requests in the questions for particular topics or things like that. We'll be following up regarding that. But one other question is, are there any examples of projects on smaller sites or urban sites that anyone can speak regarding? All right, well, it looks like we don't have any particular examples regarding that. So it looks like we're going to have to cut the Q&A section a little short. My apologies for the shortness on that. But we thank everyone for attending, and just to remind everyone that there will be a copy of this webinar or recording of this webinar available for all the attendees and registrants. And for those that aren't registrants or attendees, there will also be a copy of this on YouTube under our Go Soul Smart YouTube channel. So thank you again, and thank you to all of our panelists for their help in putting this together. And hope everyone has a great day.
Thank you.
Thank you. Take care, everyone.
Bye.